problems which involve allocating or assigning tasks are done using Hungarian algorithm. The objective here is for the task to be done in an optimal way. For instance, the objective may be that we want to minimize the cost or the time or maximize the profit. In this assignment, we want to minimize the time. Here, a furniture company has 4 employees, and each employee can perform any of the 4 tasks required to construct a wardrobe. And we have a table which shows the time in minutes each employee takes to complete each task. When we examine the table, we can see that, for instance, it takes Verity 21 minutes to perform task B. We can also see that James will take the shortest time to complete task A, and that Penelope takes the longest time to complete task C. So we want to assign each task to an employee so that the total completion time is minimized. To use the Hungarian algorithm, the information should be written in matrix form. Now we must follow certain steps. First of all, we're going to subtract the minimum value in each row from each element. Since 19 is the smallest value in this particular row, we'll subtract 19 from 24, 19, 31 and 23. And so we'll get 5, 0, 12 and 4. We do the same thing in the second row, and the smallest value here is 26. So we will take 26 away from each number in that row. In the third row, it's 25 which needs to be subtracted. And in the last row, we subtract 20. And so our new matrix looks like this, with zeros. You can see that there are zeros in every column except for this third column. So now we must proceed to step 2, which says that we must subtract the minimum value in that column from each element. Because 2 is the smallest number here, we'll take away 2 from 12, as well as all the other numbers in that column, and we'll get this column here. So that now we have a 0 in every row and every column. And so by reducing this matrix, we need to find a pattern of zeros in the matrix so that each row and each column has exactly 1 0 selected. And you can see that some of the columns have 2 zeros, and there's a row here which has 2 zeros. But we need to select a 0 so that each row and each column has exactly 1 0. If I were to select this particular 0, then I would automatically eliminate row 1 with that 0 in it. So I need to select this particular 0, because then I could select this 0 in column 3. And if I select this 0 in column 1, I have left a 0 in column 4. And as you can see, each row and each column now has a 0. The purpose of this selection of zeros is that you will now superimpose those places of zeros in the original matrix, so that the numbers you will have is 25, 19, 28 and 20. This means that we'll give Penelope task A, and we'll give James task B, and we'll give Lachlan task C, and we'll also give Verity now task D. By allocating them these tasks, we will minimize the time it takes the task to complete. So the minimum completion time will be 25 plus 19 plus 28 plus 20 minutes, which will be 92 minutes. I hope that you found this useful.